Good morning, my dear J warriors. Yet another amazing session with your captain Shreyas. In this NDA revenge, obviously, we have to we have to level up because NDA is going to throw challenging questions at us, and the competition is going to be really crazy out there. And everybody in the top thousands of ranks are going to battle it out for the most prestigious seats in the IITs and the NITs. So let's let's gather, guys. Let's start this particular session of electrostatics, Gauss law, and gravitation. Why I have coupled gravitation with electrostatics is no surprise, because the formulas, the concepts, the theories are very much similar except for the symbols. Instead of the Coulomb's constant, you have the gravitational constant. Instead of the charges, you have the mass. So let's do this together. That is the smart strategy to cover up many topics at a single go. And you will see the questions are also very much, doable when you study one of the theories. All right. So concept plus questions, and based on the current trending PYQs, for your April 2025 attempt. And good morning, Tarun. Good morning, my dear warriors, and nice to see all of you live out there. Sir, can we do it right? What do you want to do, Sri Krishna vibes? I mean, cracking J means definitely. That's the reason why I'm here, and not just with a normal percentile, with a great percentile. Namaste, Saichan. Hi, Aradhya. JEE 2027 aspirant. Wow. I know you guys are eager. I have to start making videos for you. I don't know how I'm going to make everything at once. I have lot of responsibility on me. And yeah, first of all, smash this like button. You guys keep forgetting it. Good morning, Shiva. Hi, Pranad. Let's begin. Hi, Jeffrey. Good morning. Yes, your captain is here. Let's begin, guys. So today we are going to start off with the force, then with the field, then the fields due to the charges, then the potential and the potential energy concepts, then the escape speed and the Gauss law and its flux and its applications, and Kepler's law and satellites. All the trending PYQs and those concepts which are related to that, that is what we are going to do in today's session. So starting off with the concept of force, we know any two masses placed at some distance will always attract, whereas two charges placed at some distance can attract if the signs of the charges are opposite, but they will repel if the signs of the charges are similar. So electric force can be attractive or repulsive. Gravitational force is always going to be attractive in nature. Masses are never going to be negative, at least in our classical mechanics. Okay, so the gravitational force formula that we have, is gmm by r square. It's the inverse square law, meaning if you double the distance, the force will fall down to 1/4. If you triple the distance of separation, the force will become 1/9. So it is a squared relationship and inverse, because increasing the distance drops down the forces, be it gravitational force or be it even the electric force. One more thing that you should know, the gravitational constant, which is obviously 6.67 into 10 to the power minus 11 SI units. And over here, the Coulomb constant, which is 1 by 4 pi epsilon naught, which is 9 into 10 to the power 9, where epsilon naught is the permittivity, and permittivity of that free space is nothing but 8.85 into 10 to the power minus 12. Sometimes they can give you questions for finding the units, etc., of epsilon naught or 1 by epsilon naught and stuff like that, which you can easily do because you know this is Newton, this is Coulomb, this is meter. So easily you can find out the units or their dimensions. Now, oh, I think the values were given already here. Anyways, remember the permittivity of any medium can be different. So this is for free space, meaning this is for vacuum. This is for vacuum. But if you have certain medium, then the permittivity of that medium is the relative permittivity, which is also sometimes called the dielectric constant. This is your dielectric constant multiplied by the permittivity of free space, that is your epsilon naught. So into epsilon naught into K will give you the new permittivity in that medium. So electric forces can be different for the same charges, for the same distance, but when placed in a different medium. So same two charges in water will attract differently. Same same thing if you talk about gravity, that is not the case. Okay, the forces are not dependent really on the medium. Let's also understand that superpositioning principle is valid. So if you have multiple things and you want to find the force on this particular mass or charge, then due to this guy there might be some force, due to this guy there might be some force, due to this guy there might be some force. So the net force is always the vector sum of all the forces acting on it. This is called as your superpositioning principle. Superpositioning principle. One of the direct application of that superpositioning principle is if you have a body with some cavity, if you have some body with a cavity and maybe there is some mass or charge over here and you want to find out how much force will be acting on this particular guy, the force on this particular guy, then what you need to do is this force is going to be number one, you take the whole body without the cavity. You take the whole body without the cavity, and then you just take that cavity part, and then take that same mass, then take that same mass over here, then take that same mass over here. Find out the force due to the whole body. This is the force due to that whole body without the cavity, and just find out how much force will be there just because of that particular cavity. Just how much force will be there because of that cavity. The subtraction of these two, the subtraction of these two will give you this particular force. So technically speaking, this F will be magnitude wise the net force due to the whole body minus the force due to just the cavity. This works both for gravity as well as for electricity, both. This kind of things we have been doing in moment of inertia concepts, so many other places you might have seen. We have solved these cavity based questions, isn't it? Suprabhat Diya, nice to see you guys, and very rare I get a white heart. Yeah, 87 to 99 percentile, definitely. I mean, it's not a very big jump. It's a big jump, but it's a very impossible jump. It's definitely possible. 99 percentile, it's just 180, 190 marks, 200 marks maximum. But with a difficult paper, sometimes it goes down to 180 marks. So definitely, I mean, if you have to increase 100 marks, that means you have to barely increase 30, 35 marks per subject. So that means you have to solve around 10 questions more. So if you to solve 10 questions or 8 questions more around, say for example, so you have to plan accordingly which are those chapters and those mistakes which you have to avoid. So if you have to solve some 8 questions more, maybe 2 questions you avoid silly mistakes, or 3 questions you avoid silly mistakes, 4, 5 or 6 questions you pick out from the new chapters which you might have to study. That's all. So here's a question. A small uncharged conducting sphere is placed in contact with an identical sphere but having this much coulomb of charge, and then removed to removed to a distance such that the force between them becomes this many newtons. The distance between them is, okay, come on my dear students. Thank you, Sri Krishna vibes. Always, Shweda, always, for all the JEE aspirants. Obviously, once a teacher knows the value of getting into an IIT, and once a teacher decides that I have to make many IITians and IITians, that's it. Nobody's there to stop me now. I will make sure that as long as I teach, I will produce many students who get into their dream colleges. A small uncharged, okay? So if you have an uncharged conducting sphere is placed in contact with the identical sphere with some charge on it, what will happen? These charges will start going onto this, and eventually you will see some charges will be here and some charges will be over here. They will get divided equally. If this was q, this will become q by 2 and q by 2. But now what you have done, you have taken this sphere of charge q by 2 and you have placed it at some distance, from them. So let's say that distance is r, and that's when there is a force of some repulsion between them, and that force is also given to you. That force is also given to you by our Coulomb's law. That force will be our Coulomb's constant into charge 1 into charge 2, the whole thing divided by r square. Take r square over there, so it will become k into q square. 2 2s are 4, and this force will come over here. The value of k is 9 into 10 to the power 9. Please remember, this is r square. This is charge square, which is nothing but 4 into 10 to the power minus 8, and this is whole squared. The whole thing divided by 4 into the force. The force is 9 into 10 to the power negative 3. Now, as you can see, 9 will get cancelled. 9 and minus 3 will become 10 to the power 6. This is 4. And this will become 4 into 10 to the power negative 8. And this is the whole square. That is r square, please mind it. But I just want r. So taking the roots, this will become 10 to the power 3. This will become 2. The square will vanish. So it will become 4 into 10 to the power negative 8. So 4 by 2 is nothing but 2. This is 3 and this is minus 8. So this will become minus 5. So 2 into 10 to the power minus 5 meters. 2 into 10 to the power minus 5 meters. That is what the answer is coming, unless we have made some thing. So it should be B, I believe. It should be B. But I think the power is wrong somewhere. Maybe some of the units, I'm not really sure whether it is 8 or something else then. Okay, so I'm getting 2 into 10 to the power minus 5. Just see if the powers somewhere has been missed by us by any chance. So this was 9 into 10 to the power 9, 4 into 10 to the power minus 8 only, I believe. Yeah, okay. And the force is 9 into 10 to the power minus 3. Okay. Oh, yes, I know what mistake we did. Sorry, guys. When I cancelled minus 3 and 9, sorry, I think I made a mistake here. Sorry. Minus 3 will go on the top. It will become 10 to the power 12. So sorry, this was 10 to the power 12. Okay. So 12 and minus 8. 12 and minus 8. So this will become basically 10 to the power 6 after taking the root. Yes, 12's root is 6. 12's half is 6. So 6 and minus 8, this will become minus 2. Yep. So it will become 2 into 10 to the power minus 2 meters, which is 2 centimeters. Perfect. Now it is correct. So 2 centimeters, guys. Yeah. We missed the power. By mistake, I cancelled 9 and minus 3 and made it 6. That was a silly mistake. So 9 and plus 3 should have become 12. My bad. Going to the next one. A small point mass is placed at a distance of 2r from the center O of a big solid sphere of mass m and radius r. So this guy's radius is r. From the center, this distance is 2r. The whole mass is m. The gravitational force on small m because of capital M is F1. Now you take out some part of radius r by 3 from the big sphere as shown, and the new gravitational force on M due to the remaining part is F2. So the older force is F, the newer force is some F2. The question is, what is that ratio of F1 by F2? So let's do one thing. Let's find it out 2 times. First time, let's consider the entire sphere, guys. Let's consider the entire sphere and let's find out how much force will that give? How much force will that give on M? So that is basically F1. Now this entire mass can be assumed to be concentrated over here at point O. So now these are like 2-point masses, and therefore that force F1 will be nothing but G capital M small m, the whole thing, divided by the total distance of separation, which is 2r, the square. So it will be GMM divided by 4r square. Is that right, my dear students? Yep. Everybody till this point? Clear? Yes, sir. Okay. Now the next point. Because I want to find the force only due to the remaining part, which means just this much, just this much, not the cavity. I will do one thing. I'll just find out how much force will come only because of the cavity. That will not be F2, it will be some F3, let's say, just because of that cavity. Okay, to do that, first of all, how much is the distance of separation? Well, the radius is given to be how much? R by 3. So this much is R by 3. This much is R by 3. This was 2R, this was R, and therefore this much was definitely R. So from the center to here will be R plus R by 3, R plus R by 3, which is nothing but 4R by 3. That is the distance between this point and the point P. How much will be this mass? Well, the logic for that is as follows. We know that the mass for a constant density is proportional to the volume, and the volume is proportional to the cube of the radius. The cube of the radius. 4 by 3 pi r cube. That's the volume of a sphere. So, if the mass is completely m, the radius was, let's say, r, and now if the mass of that particular cavity has to be found, the mass of the cavity, the radius is r by 3, the radius is r by 3. So since it is proportional to the cube of the radius, proportional to the cube of the radius, so just do the simple unitary method. Mass is proportional to cube of radius, so m by mc is r cube by r by 3 cube. That's it. So therefore, m by mass of the cavity is r by 3 the whole cube. So what will this become? Think about it. So this will become m by mc is equal to r cancels. 3 cube is basically 27. So therefore, mass of the cavity will be the total mass by 27. Total mass divided by 27. Everybody with me till this point? Yes, sir. Perfect. Now find how much force will be there because of the cavity. How much force will be there because of the cavity. So that force, observe. So that particular force because of the cavity will be G m of this guy, which is m by 27 multiplied by small m, whole thing divided by the distance square, which is 4r by 3 the whole square. So you will have gmm by r square as it is. We have 1 by 27, 4 square is 16, 3 square is 9. So 9 goes on the top because it will be squared by 3. Okay, so 9 and 27 will cancel. So gmm, correct? 9 and 27 will cancel. This will become 3 and this will become 16. 3 into 16 is nothing but your 48. So 48 r square. So that is the force because of the cavity alone. That is the force because of the cavity alone. Now the logic is as follows. Now the logic is as follows, that if you talk about F2, which is the force, because of the remaining part, the force due to the remaining part, which is already mentioned over here. F2 is that force because of that remaining part. Then that will be obviously the total force of the entire body minus the force due to the cavity. That's all. Whatever force you found out due to the cavity, if you subtract from it, you will get the force due to the remaining part of the body. And now we have to basically find what is the value of F1 divided by, you have to find what is the value of F1 divided by F2. So naturally, F1 is on the top, so F1 will come over here as it is. F2 is F1 minus your FC, so that will come over here. So start substituting the values now. So what is F1? F1 is nothing but GMM divided by 4R square. So GMM divided by 4R square minus your force due to the cavity, which was GMM by 48R square. So this was GMM by 48 times of R square. GMM gone. R square gone. 1 by 4, 1 by 4, 1 by 4 also gone. So I will be left with, check this out, 1 divided by 1 minus 48 and 4, guys, it will be 1 by 12. Is that right? So how much is that particular answer going to be? 1 divided by 12 minus your 1. So 12 minus your 1, the whole thing divided by 12. So it will be 12 on the top and 11 over here. So 12 by 11, guys, that is nothing but your option B. 12 by 11, which is your option B. Isn't it amazing? The manner in which you have to solve this question based on the concept of superposition principle. So first we found out the force due to the entire body, assuming the mass at the center, which was very simple, gmm by the total distance square. Then we said, let's find out the force due to the cavity. So first we found out how far is the center from this mass, how much is this mass by using mass proportional to the cube of the radius. The mass was 127. So we found out the new force due to the cavity alone, which was this much. Then we said the force due to the remaining part will be the total force minus the force due to cavity. So then we had to take the ratio. We just substituted the values and we got the answer. Cool? Understood how to solve this? These kind of questions were very common, by the way, in the January attempt. Expect some kind of questions, maybe at least in few shifts. Moving on to the next one. There are two planets, A and B, orbiting a common star in circular orbits of radius RA and RB. RB is double of RA. Planet B is this many times more massive. It's more massive than that planet A. The ratio of the angular momentum of B to that of A is to the nearest integer. How much? No issues, Ashmita. Just join in to the questions. Whatever you miss, you can watch it later on. Don't worry. All right. So let's do this. Two planets are orbiting a common star. Okay. So let's draw the diagram first of all. Okay. So let's say this is your common star. So this is your common star, you can say, and they are orbiting with two different radius. One is over here and one is like this. Okay. The second radius is double of the first radius. Okay. That is also given to us. So if this is RA, the next one is double of it. So if this is RA, this is your RB, which is 2 times of RA, I can say. The masses are also given to you. The mass of A, if I take it as, let's say, small m, the other guy's mass, planet B's mass, is 4 root 2 times. So 4 root 2 m. That is what this is. Obviously, you have to find the angular momentum. So they will be moving like this with different speeds. Is that right, everybody with me? Very good. So now, how do you find the angular momentum? How do you find the angular momentum or ratio of both of them? Well, you can start solving this by gravitational force and then equating it to centripetal force and all of that. And then we can start doing this, I believe. So if you just do it in general, the gravitational force will be mass into centripetal acceleration. Gravitational force will be G, mass at the center, mass of the planet divided by the distance square. Centripetal acceleration will be V square divided by R. Okay, R will cancel. So mm will also cancel. So therefore V square will be Gm by R, or rather V will be root of Gm by R. Root of Gm by R. M is the mass of the star. Now we will find out what is the angular momentum. Now we'll find out the angular momentum in general. Angular momentum is mvr. So mass of that planet into speed, which is root of gm by r, root of gm by r into r. So r and root r will cancel. So it will become m root of capital G, capital M, and the radius. That is your angular momentum. So now I want the ratio of the angular momentums. So L1 by L2, think about it, will be m1 by m2. Root gm will be the same. The only thing which will be different will be radius. So it will be r1 by r2, which in this case is a and b. So that's all you have to think of. So actually I can put angular momentum of a upon angular momentum of b will be mass of a upon mass of b and radius of a upon radius of b. So what is mass of A? It is m. What is mass of B? It is 4 root 2 times of that mass. Okay, what is the radius of A? Let's say it is RA. RB is the double of that radius of A. Okay, so what will that ratio become? Mm cancels, so 1 by 4 root 2, of course. RA cancels, I will just have 1 by root 2, of course. So this will become 1 by 4. Root 2 into root 2 is 2. So 1 by 8. So 1 by 8 is the answer. Is that okay, everyone? But they have asked LB by LA. So this was nothing but LA by LB. So if they have asked LB divided by LA, so that will be 8 by 1. So the answer which will come over here will be 8, I believe. Yes, it is answer 8. Directly, you can do this. Okay, awesome. Thank you, Moganti, for letting everyone inspire to smash that like button. Thank you so much. Yep. So that is the correct answer. So these are the kind of questions which you can expect from forces, guys. I am taking some good questions. I'm not doing easy questions deliberately. If you are wondering, sir, can you do some very laddu questions? Guys, I've told you this 100 times. I mean, JEE means April attempt. If you keep doing laddu questions, then again you will expect 70 percentile, 80 percentile only. You will not even cross 90 percentile. You have to do challenging questions. Okay. So let's do the next concept of field. Field is present around any mass or any charge, and the moment I say there is a gravitational field or electric field, that means any other charge or any other mass you place in that field will experience the force. And field is defined as how much force you experience per unit mass in case of gravity and per unit test positive charge in case of electric fields. So when you talk about electric field, when you talk about gravitational field, then the formula for gravitational field is E, which is force per unit mass. So it is something like acceleration due to gravity only. You can say it is something like acceleration due to gravity. So it is the force acting per unit mass, and also you can say vice versa. If by chance there is a gravitational field and in that you place a mass over here, then that mass will experience a force, and that force will be given by the mass into the value of the gravitational field over there. Correct. This same thing in electrostatics is force per unit charge instead of force per unit mass. It is always per unit charge. Yep. And same logic applies there also. If you have an electric field and in that you place a electric charge, then it will experience a force given by the value of the charge into the electric field. Please remember, if the charge is negative, then the force will be in the exact opposite direction. It will be in the exact opposite direction. If you take a single point charge and you try to find the field due to that point charge, the formula is 1 by 4 pi epsilon naught, which is that constant, into the charge divided by r square. Just remember, the force had kqq divided by r square. Now that q is not there because you have divided the force by the charge to find out the field. So the electric field due to a point charge is just kq by r square. Whereas if you talk in terms of gravitational field due to a mass, so if there is a mass over here, there is a distance, and here you're trying to find the gravitational field, then that will be gm divided by r square. That's the formula for the gravitational field, gm by r square. If you plot the graph of these things, whether it is gravitational field or whether it is electric field, doesn't matter. The formula, because it has r square in the denominator, the field versus r graph always comes out like a curve. Yes, it is like a curve like this. Okay, keep these things in mind. Yep. Awesome. So with this, let's start doing some question. By the way, it follows superposition principle. So I can just mention that as a side note. It follows superposition just like before. So if there are multiple charges, or multiple masses, each mass will apply its own field, and you will have to find the net field by adding the fields as vectors only. Yes, not scalars. Follows superposition. It follows superpositioning principle. Superpositioning principle. Yes. Some basic formulas of fields which you should be aware of are like, if you take a solid sphere versus a hollow sphere, I'll just do for gravity. The same thing applies for electrostatics. No point doing it two times for the same thing. So once for the solid sphere and then for the hollow sphere, guys. So this is for solid sphere or uniformly charged sphere. This is basically a hollow sphere or basically a shell or basically a conducting solid sphere. Conducting solid sphere. Conducting solid sphere. Because in a conducting solid sphere, the charges only come on the periphery. So even though it is filled inside, there is no point of that mass inside because the charges only come on the periphery. So it behaves like a shell. So a shell, conducting solid, hollow sphere is one and the same thing. Complete solid sphere of mass or uniformly charged sphere is one and the same thing. So what are the formulas for the field? If you talk about the shell, then the electric field or gravitational field inside is always zero. But the moment you go outside, then the gravitational field is gm by r square, or you can say kq by r square in terms of electricity. Yeah, this r is the total distance irrespective of what the radius of that shell is. Whereas for the if you talk for the solid sphere or a uniformly charged sphere, then the gravitational field inside is gm divided by, yes, there is radius cube, the radius of that particular sphere, that r will come over here, and then you will get small r. In case of electricity, it is nothing but kq divided by, here you will have small r, and then capital R over here Q. That is what the difference is. Instead of G, you have K. Instead of mass, you have Q. Yeah, it is proportional to R. Keep that in mind. This is inside. Outside, it is the same thing as that of a shell. That means the entire mass is assumed to be concentrated at the center. So it will be Gm by small r square, or you can use Kq divided by small r square. Yep. Is this absolutely clear, my dear students? Very, very important formulas. Last important formula for field which you find using superpositioning principle is for a ring, where you have a ring of certain radius, certain mass maybe, and you are placed somewhere on the axis. You are placed somewhere on the axis. Then the field that you will experience in case of gravity will be gm x divided by r square plus x square raised to 3 by 2. In case of electrostatics, it is kq x divided by r square plus x square raised to 3 by 2. So that is the only difference. Instead of gk, instead of m, q. So for electrostatics, if you know one formula, automatically you know the other formula. This is for a ring. This is for a ring which is either charged or the rings of Saturn, and you want to find the gravitational force due to the rings of a planet which might be there. Like many planets are there in our solar system and even otherwise, which have rings. So that is why this geometry also becomes important. Let's start solving some questions. Electric field. Oh, so sheet also is there. So let me just complete that part also. So let me also give the sheet things as well. And for a conductor. So guys, let's say you have, and this is only there for electrostatics because masses are not present in the form of a sheet. So that's why that formula you don't study. If you have a charged sheet, then the electric field will come both sides and is uniform, and that electric field is sigma by 2 epsilon naught. This sigma is nothing but how much charge is there per unit area, coulomb per meter square. The surface charge, the charge density, the area charge density on that sheet, charge per unit area. Because the field goes both ways, both means 2, so that's why that number 2 will come in the denominator. But imagine you have a conductor, and you are talking about the field on the surface, of a conductor. This is the field on the surface of a conductor. So we know that for a conductor, the field inside is always going to be 0. It's only the surface where the field starts to originate, because all the charges will always be on the surface, never inside. So that field on the surface of a conductor, is sigma by epsilon. There is no 2 over here. Why there is no 2? Because the field is going only on one side, not both sides. So one side, 1 means 1, number 1. So number 1 is coming here. It goes both sides, both is 2, so 2 comes here. That's a quick trick to remember these formulas. Is that okay? Great. Lastly, you have a finite wire which is charged, or an infinite wire. You can have those special cases also. So finite case is the most important case. From that you can get anything else. So if you have a finite wire like this, and let's say this is distance r, and let's join the endpoints like this. So let's say this is alpha, this is beta. Then the electric field over here, okay, so this is a charged wire. And this wire has lambda charge density, which is how much charge is there per unit length. Then that electric field is given by, listen to me carefully, K lambda divided by R. K lambda, K is Coulomb constant, lambda is your charge per unit length, divided by R, not R square. And then you have sine alpha plus sine beta. Keep this in mind. Now, if by chance, very special case, if it was infinitely long, then alpha and beta will be both 90 degree. Alpha and beta, which are the angles made by the perpendicular with the ends of the wires. This wire will be infinitely long, so alpha will become 90, beta will become 90. So then that electric field will become just K lambda sine 90 plus sine 90, obviously 1 plus 1, which is 2. So 2K lambda divided by R. So that is what it would be if it was infinitely long. Yeah, cool. So these are the things which you should, definitely remember. We can start with the questions now. Okay, read the statements. There are some formulas in the list to match the correct statements with the formulas. Yeah, similar to the magnetic field. Yes, correct. Magnetic field also very, very similar. Correct. Okay. Come on, my dear students. Electric field, which is inside, R is the distance from the center of a uniformly charged spherical shell. Spherical shell, be careful. It's a spherical shell. So charges are only there on the periphery with the surface charge density sigma. And you have to find it inside. What will it be inside? Yep, 0, no? Inside a charged shell, no matter where you go, it will be 0. So I think A will go with 3. A will go with 3. Guys, there is only one option. Will you waste your time in the exam? To check A, B, and D? Do you have so much of time? If you have so much of time, please pass it on to somebody else. I mean, really, nobody has so much time. You have to complete the paper. Completing the paper only itself is a challenge. Okay. So, my dear students, the answer will be C. Yep, you don't even have to check the others. Yes, it is. It is C. But still, if you want to check and see whether everything else matches, this is just for clarity's sake, or if there were two options with the same thing, then you have no other choice but to check the other options. The electric field at a distance of a uniformly charged infinite plane sheet. This is a infinite plane sheet with a surface charge density sigma. What will happen, guys? The field will go both ways. So it will be sigma by 2 epsilon naught. So B is with 2. Perfect. B is with 2. Perfect. Electric field, which is outside a charged shell with some density. When you go outside, it is inversely proportional to R square. So C is basically 4. Yes. So electric field outside of a shell, obviously inversely proportional to R square. And the last one, obviously, the field between two oppositely charged infinite plane parallel sheets with uniform surface charge density, that is going to be your sigma by epsilon naught. So electric field which is between infinite parallel sheets, this is like your capacitor. Between the plates of a capacitor, the field is sigma by epsilon naught. If you remember the field derivations, the derivation of parallel plate capacitor, or the force between the two plates of a capacitor, those things, if you remember, you will be able to answer that fourth one. Yeah, the D1. Okay. Yeah. So that is the answer. Moving on to the next one. Particle of certain mass, okay, and charge q is fastened to A, having of a massless string having equilibrium length L, whose other end is fixed at point O. The whole system is placed on a frictionless horizontal plane and is initially at rest. If a field is switched on along the direction as shown in the figure, right side, then the speed of the particle when it crosses the x-axis. Okay, come on, my dear students. This is a beautiful question again over here. So all the distances need to be, yeah, it's given. All right. So field is over here. So the field is over here. The charge is over here. So naturally the force on A will be in this direction. So electric force will be charged into electric field, will be the charge into the electric field. Charge is Q, electric field is E. But there is also gravitational force which will act downwards. We cannot ignore that. So there will be gravitational force, and that will be nothing but mg. I think G is not even there right now. Okay, we'll just put mg over here. Okay, the speed of the particle, speed of the particle when it crosses the x-axis. The x-axis is over here, and because the string is there, this electric force and gravitational force together will pull it this side. So their string will be tight, and because the string is tight, because you are pulling it, there was that string, you are pulling it, so the string will be tight, and the gravitational force is also pulling it down. So eventually what will happen? It will go down like this. It will go down like this. It will go in a circular path. Won't it go in a circular path, my dear warriors? Won't it go in a circular path? Everyone? Very good. Very good. Excellent. Awesome. Awesome. That is what it will essentially do. Correct. It will, yeah. But nowhere they have mentioned about gravity. Now, horizontal plane initially. Okay. Let's see what to do about that. Now, what will happen once it goes over here? From this point to this point, will gravitational force do work or will electric force do work? Tell me, guys, quickly. Will gravitational force do work or electric force will do work, or both of them will do work? Because by the time it reaches here, obviously it will gain some speed. It will have some kinetic energy. Here it was at rest. So it was here, then here, then here, then here. So in this process, it has gained some speed. So quickly tell me, there is some gain in the kinetic energy. So final minus initial kinetic energy. So who is doing work? Definitely gravity is there, and definitely electric force is also there. Both of them are doing work. Both will do work. Prakrutik, so glad you have been watching since Jan J 2025. So glad. Yesterday I saw one comment on the channel, and that student was saying, "Sir, I have been watching your videos since last 4 years." That means the student was in ninth standard when they started watching JEE videos. So that's a very good hack. And I know by checking the analytics of the channel, I am seeing there are some 13-year-olds and 14-year-olds, which means you are, I think, in ninth, 10th standard, that range, who are watching JEE videos. And that's a significant chunk. And I'm extremely glad that this channel has been a boon to all the South Indians and the Northeast students who prefer to learn in English. But that was the intention initially. But the best part is, we didn't even expect this and we didn't even know this. Most of the students in India, I mean, can you believe, everywhere, even in North, even in Maharashtra, Gujarat, Kashmir, Delhi, UP, Rajasthan, everywhere students are watching in English. So, things are changing. We are going global, we are going international, we are going bigger. And I'm so glad. Thank you so much, guys. So, yeah, out of these two, you know what? Lot of people did not know this. What you have to do? The gravitational force will do negligible work. Can you guess why? Negligible work. Can you guess why? Because always electric force is the strongest force as compared to the as compared to the gravitational force. So electric force is stronger than gravitational force. So even if gravitational force is there, that can be neglected in front of electric force. It's just what happens with you. It's just like what happens with you maybe at home. When you are at home, you ask for some juice or some favorite dish and you ask your mom or dad, like, okay, yeah, here, take it. Yeah, okay, you want this chocolate. Okay, you want this parotha. Okay, you want this special dosa. Fine, I'll make it for you. But then suddenly some guest comes, or maybe your mom or dad's favorite person or some cousin or somebody has come, and then you ask, hey mom, hey dad, you know what, I want this. And they're like, no, 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 wait, that person is here, he or she likes that thing, so we are going to make this special dish for him. Don't like that. I don't care, I'm going to make it for you. You get automatically neglected. Same way, the gravitational force becomes negligible as compared to the electric force, because electric force is much stronger as compared to the gravitational force. Is that clear? Yep. Yeah. So what is the work done by electric force? Force into the displacement. So what's the displacement? The displacement is only this much. So for that, you need to drop the perpendicular. And we all know that this entire length was L, and just this much length was L cos 60. So if you look at this much, which is the displacement in the x direction, the displacement in the x direction will be the total L minus L cos 60, which is L minus L by 2, which is again L by 2. So therefore, I will get work done by gravity negligible, work done by electric force is the displacement in the x direction into that electric force. Kinetic energy finally is half m v square. Initially it was at rest, so this will be just half m v square. Displacement in the x direction is L by 2 multiplied by the electric force value was nothing but Q into E. Question was to find that speed. 2 will get cancelled, of course. 2 will get cancelled. So you will have LQE, and m will come below, is equal to v square. So v will be root of LQE divided by m. LQE divided by m. That is option C. Beautiful question. This was framed. Is that clear, everyone? Oh, GKM VIP, you got 98.9. Wow, that's cool. I really hope this time it becomes 99.9. That will be an amazing dream come true. I really hope things work out your way. Whatever you have studied comes in the exam. Everything, favors you. Yep. Let's go, guys, to the next concept of acceleration due to gravity and their questions. Right? Ready for it, guys? When should we consider the gravitational forces, sir? I mean, in string problems. Yeah, when electric forces are absent. When electric forces are absent, or in the options you see G is there. But Usually in options, G will not be there if electric forces are there, unless specifically it is mentioned that you have to consider the gravitational force, or you notice that the value of the electric force is very less and gravitational force is strong by value. So only in that cases, otherwise negligible. Okay, and just look at the options. Most of the time options will give you the hint, nowhere G is there, nowhere G is there. So that will immediately tell you that, listen, ignore the gravitation. Okay. Acceleration due to gravity. Well, we know that if you consider the surface, if you consider the surface of Earth, if you consider the surface of Earth, the acceleration due to gravity on the surface is G, mass of the Earth, divided by the radius of the Earth. So R over here is obviously the radius of the Earth. But then sometimes you go up and let's say the height is h. So let's say this much is h. So at this point, the gravity at height h is Gm, same formula, just that now the total distance will be r plus h whole square, which approximately becomes this same G which is on the surface, G on that surface, into very important 1 minus 2h by r. This approximation is valid when h is much smaller than the radius of the Earth. This is the exact formula, that's why equal to. But when height is very small, like few hundred kilometers or few meters, then you will use this formula, which is at height h. G on the surface, same thing, Gm by r square, 1 minus 2h by r. Okay. Similarly, let's go down and see what exactly happens. So let's say you are over here. Let's say you are over here. This is r. And you can go the other way around also. This is basically d. So at this particular point, this is depth. This is the distance from the center. Both ways you can get it. So gravity at some depth, gravity inside, can be written down as Gm small r divided by r cube. This is one way in terms of small r, but you can also write in terms of depth, which is again gravity on the surface into 1 minus d by r. Please note this is exact formula, because this formula looks very much similar to this. The only difference is this is not having that number 2, this had that number 2 over here. This is above, this is below, this is approximate, this is exact, valid for all the depths. Depth need not be small or big, it can be anything. It can be anything. So these are the formulas on the surface at height h and below the surface of the Earth. Also note that when the Earth spins, there is a centrifugal force which comes into play, because of which the acceleration due to gravity will be slightly different, and you will get the formula as the actual gravity minus omega square r, where this omega is the angular velocity of rotation. Angular velocity of rotation. So angular velocity of rotation, r, is basically the radius of the Earth. So there is a small difference which comes. So because of which you will see the gravity at the equator, because of the centrifugal forces, is less than the gravity on the poles. This is not the only reason. There is also one more reason, because the Earth is bulged out. So the equator is far away. So the gravitational effect becomes less, whereas the pole is slightly closer to the center. So the gravitational effects are slightly higher. So both the reasons of rotation and the ovalish shape of the Earth makes the gravity at the equator less and the gravity at the poles slightly higher. 9.8 is an average value of all the places on the Earth. So let's do some questions. Assuming the Earth to be a sphere of uniform mass, body weighing 300 Newton on the surface, how much will it weigh at a distance of r by 4 depth under the surface of the Earth? Come on, this is very straightforward, guys. This is very straightforward. I want everybody to spam the answer and give it to me. Meanwhile, I'll just get some water. Hmm. See, when you are inside, everything is linearly proportional. You would have seen this. Everything is linearly proportional to R. So that's it, guys. I mean, like, so gravity is gravity at the depth d is gravity on the surface, let's say g naught, into 1 minus d by r, where this d is r by 4. So this will be g naught into 1 minus, if you put r, it will be 1 by 4. 1 minus 1 by 4 is 3/4. So 3/4 of g naught. So that is gravity at depth d. So weight at depth d is the weight on the surface multiplied by 3 by 4. Weight on the surface is how much? 300. So 300 multiplied by 3 by 4, which is nothing but 225 Newton. 225 Newton is the answer. Perfect. Yeah. So that's it, guys. I mean, like, depth, if you put it 1 r by 4, 1 by 4 and 1, that will be 3 by 4. So you will automatically get 3/4 of the gravity. So the weight will also be 3/4. Cool. If it was at a height h, then tell me which formula will you use? Will you use the exact formula or will you use the approximate formula? If it was above the surface of the earth. Everybody let me know in the answers in the chat box. If it was above the surface, will you use the exact formula or will you use the approximate formula? That's the question. Come on, come on, come on. Everyone, let me know quickly. Hello, Jan1. Come on, everybody. Very good. Many of you spammed the answer correctly. Very good, Moganti, GKM, Darni. Very good, RS Asmita. Awesome, guys. Awesome. Very good, Miles. Yep. So what do you think? Yes, you have to use the exact formula because R by 4 is not negligible. Correct. Very good. Cool. Let's move to the next question coming up on your screen. Acceleration due to gravity on the surface is g if the diameter of the earth is reduced to 1/3 and the mass remains unchanged, then the acceleration due to gravity on the surface will be. Oh, this is direct, I think. Gravitation value on the surface is gm by r square. Clearly the mass is not changed, the diameter becomes 1/3. See, clearly it is mentioned the mass remains unchanged, whereas the diameter is made 1/3. So if diameter is made 1/3, what will happen to the radius? Obviously, radius will also become 1/3. Is that right? So from here, it is obvious that the new gravity by the old gravity will be the old radius by that old radius by that new radius whole square, inversely related to each other. You can see it is inversely related to each other. So therefore, the new gravity upon that old gravity, which was g, the old radius r1, let's say it is r, the new radius is 1/3, so r by 3 whole square. So therefore, g2 will be, g goes on the top, this 3 comes on the top, whole square. So 9 times of g, I believe. 3 will come on the top, RR has cancelled. So 3 square is 9. So 9 times should be the answer. Yeah, direct. Inversely proportional. Yep, very good. Many of you gave the correct answer. Darni Moganti, excellent. Jan 1. Yes, mango. Perfecto. Amazing. Others. Yes, correct. Self-cooking 9. Yes, Adam 10 minus 1. Very good. I hope you will not write such things in the exam. 10 minus 1, 1 plus 8. Yeah. Although it is correct answer, computer will not take it, unfortunately. But if you played along like that in the in the CBSE boards, all the best. Okay, cool. Let's go. Let's go. Gravitation and electric potential energy. Okay, what to do? Yes, gravitational and electric potential energy. Whenever you have multiple charges together, they possess energy in the form of potential. If it is due to masses, it is gravitational. If it is due to charges, then it is electric. So whenever you have two charges, the electric potential energy is given by the electric potential energy due to a system of two charges is given by KQ by R, not R square, just R, due to two charges. Due to two charges, the electrical potential energy is KQQ, 1 by 4 pi epsilon naught is K, Coulomb constant, by R. But in case of gravity, instead of K, you will have G. Instead of charge, you have masses. Again, R will come, but there is a small catch. There is a minus sign. So be careful. Whenever those potential energies are negative, that means whenever the potential energies, even in electrostatics, it can be negative. That means it is due to attractive forces. Attractive forces. For example, one is a proton, one is an electron. Positive into negative will make it negative. So take the energy as negative. Don't say, oh, I got the answer as negative, I will take the modulus. No, don't do that. Same way, if it is positive, that means it is repulsive in nature. That means it is repulsive in nature. Got it? Very good. Okay. Now, having said that, if you have multiple masses or multiple charges, then each pair of mass or charge, each pair of mass or charge will possess energy. Yep, that is how it will be. Each pair of mass and charge, I think I've taken almost everything. Yep. So will possess energy. Will possess energy. So if you want to find the potential energy of a system, take all the combinations ij, wherever I is not equal to j, that summation will come. That will give you the total potential energy of that particular system. Very important again. The total potential energy of the system is taking the potential energies of each pair of charges or masses and adding them up. Please remember, signs have to be considered. Okay? Be careful. I will just mention that over here. Consider the signs also. Consider signs also. If some are positive, some are negative, don't say negative, I'll make it positive. No, make that sign or keep that sign as it is. Don't play with it. Okay, cool. Now, sometimes you change the configuration. Maybe the masses are moved around and maybe one mass is brought here and this mass is here, this mass is here. So the moment you have changed the configuration, yes, imagine you have essentially changed that particular configuration. Yes, almost everything I think we have taken care of. Yeah. Yeah. So essentially, if you end up changing the configuration, change the configuration or the state, then the potential energy changes. So therefore, there will be a change in the potential energy of that particular system, and that is nothing but your final potential energy minus initial potential energy. Please note that this change will be exactly equal to the work done by the external agents or the forces, but also it will be the negative of the work done by the electrical forces, by the electric or the gravitational forces. Please keep that in mind. This is a very, very important equation, basically not because of the magnitude, but because of the sign. Remember, work done is negative delta U. So that work is always the work by conservative forces. Electricity, gravity are conservative forces. So negative of the work done by the conservative force is the change in the potential energy of the system. Very important, guys. And that's why you always had du is equal to minus the work done by the conservative forces, which is nothing but minus the force of conservative into distance. Work is force into displacement, and that is why you used to have the conservative force. That is why you used to have the conservative force equals to minus du by dr. Yes, minus du by dr. That is why that formula used to come. Okay, so always negative of the work done by conservative, but positive of external force. This is the most important formula, guys. Please remember this. Cool. Let's do some questions based on this. Radius of the orbit, planet. Okay, satellite related questions. So shall I just give you the formulas then? Okay, so shall I give the formulas? So for satellites and everything. All right. So let me give you the formulas then. See, first of all, if you take a shell, if you take a shell of certain radius, okay, and let's say you have placed a point mass or point charge at a distance of r, then if you are inside that shell, no matter where you are, the potential energy will be the same. It will be basically minus gmm divided by r. In case of charges, it will be kqq divided by r. This r is this, please mind it, the radius of the shell. So essentially it is saying that it will be a constant no matter where you are if you are inside, but the moment you are outside, it's the same formula as of a point mass. So minus gmm by small r, not capital R. So it will be kqq divided by small r. So that's the formula if you are taking a shell. Similarly, if you are taking a ring-like object, if you are taking a ring-like, object, radius is r, and on the axis of the ring, you are placing some mass, then the potential energy is given by, for gravity it is minus gmm divided by just root of r square plus x square. In case of electrostatics, it is just kqq divided by root of r square plus x square. There is no minus here, there is minus here. So that's for a ring. Similarly, if you are considering there is a planet over here, and in the orbit there is a satellite which is revolving, let's say like this. So this is m, this is capital M, and let us just say this particular distance is the r, which is the radius of the orbit. Then it will have total energy, guys. The total energy of that satellite will be minus gmm by 2 times of r. But if you just talk about the kinetic energy, that kinetic energy will be just negative of the total energy, and the potential energy of the satellite will be nothing but 2 times of the total energy. So negative of this means just gmm by 2 times of r, and 2 times of this means that 2 will go off, so minus gmm divided by r. These are very similar to Bohr's models of atoms, where the electron's kinetic energy is the negative of the total energy, which is minus 13.6, and the potential energy is double of that total energy of that electron. This 13.6 electron volt, remember the Bohr's radius, first orbit. Yeah, so same formulas are applicable even in electrostatics and even in gravitation. Just the things are changing a little bit in terms of variables. Is that okay? All right. All right. Okay. Thank you so much, GKM VVIP. Means a lot when you say such things. And thank you for promoting the channel. And I would really appreciate if you do the same thing to your juniors and your batchmates and maybe your younger ones somewhere down the line. Okay. It will really mean a lot. Okay. So these are the formulas. So let's start doing these questions. Match the following: radius of the planet, radius of the planet's orbit, mass of the sun, mass of the planet. Choose the correct options. Oh, now you should be able to do it very easily, guys. Kinetic energy of the planet. It will be 100% positive. Kinetic energies are negative. So it can't be 4, it can't be 1. Now, whether it is this or whether it is this, it depends on the radius of the orbit of the planet, never the radius of the planet or anything else. So A should go with, I think, 2. Yeah, A should go with 2, I believe, kinetic energy of the planet. Yep, check this out. It should be GMM by 2A. Negative of the total energy of that particular planet around the sun will be minus GMM by 2A, and kinetic energy will be negative of that total energy. So negative of this will become GMM by 2A. So A is with 2, A is with 2. Oh, directly A option. Yep, A option is correct. No need to check also. So usually match the following. It becomes easy because only one of them will be or maximum two times you have to check it. But in JEE Advanced it is not like that. You will have to check it many times. Okay, because it is matrix types and one will match with many things. Okay, anyways. What about B? Gravitational energy of the sun planet system. Well, obviously, it will be nothing but minus GMM by A. That is your potential energy. Yes, the gravitational potential energy will be B, will go with 1. Nowhere else it is going with 1. Yep. Remember, the potential energy will be double of that total energy. So double of this is obviously, double of this is directly nothing but minus GMM by A. Lastly, we can also check one more thing. The total mechanical energy of that planet will be obviously minus GMM by 2A. That is exactly what I have written, total mechanical energy. So C is going with 4, of course. And then escape energy of the surface of the planet per unit mass. It depends on the radius of that planet. Yes. So that will be exactly this. That will be exactly this. All the things will match. Moving on. Astronaut takes a ball from Earth to space. He throws the ball into circular orbit about the Earth at an altitude of 318.5 kilometers from the Earth's surface to the orbit. The change in the total mechanical of the ball is this much times of GMM by 21 R. What is the value of X? And the radius is 6370 kilometers. That is also given to you. Okay. Come on, my dear students. What will you do now? What will you do now? Think carefully. Yes, what will you do now? You are taking the ball, he is throwing the ball into circular orbit. From the Earth's surface to the orbit, the change in the total mechanical energy will be how much? So, first of all, initial energy at the Earth's surface, he had only potential energy. So, let's call that energy as, let's say, E1. That will be only potential energy. So it will be minus GMM by the radius. There is zero kinetic energy. There is only potential energy, guys. Kinetic energy is not there. So when he goes on the top, and he's putting it into an orbit, so obviously now, there will be, yeah, obviously now there will be, what do you say? Kinetic energy also and potential energy also. So the total energy will be given by minus GMM by 2 times of the radius of that orbit. Yes, this includes your kinetic energy and your potential energy. This is the total energy of a satellite in that orbit, 2 times of R. Now, what is that R? We'll come to it. But we can find out that R right from here. It is the radius of Earth plus the altitude. So it will be 6370 plus 318.5. That is your radius. Is that right? Plus 318.5. Come on, guys. Now we have to just find the change in the mechanical energy. That's what is the question. So we are going to take this and subtract the 2. So the change in the mechanical energy means it is E2 minus E1. So it will be minus GMM by 2R minus this thing minus GMM by R. So you can see GMM is common and you have 1 by R minus 1 by 2 times of small r. So now it's just a matter of substituting things, but everything is in terms of r of that particular planet. So guys, think 318, is it a multiple of 6370 by some way? Is it a multiple of it in some way? Just think about it, my dear students. can we take it as a multiple of it so that everything will be in terms of the radius of the earth? I think we can do that. Maybe. Just think about it. How many times is your 318 as compared to 6370? Yep, 318 as compared to 6370. Is it some multiple approximately? Is it some multiple, guys, approximately? Just check it out. Yeah, I think it will be some multiple. Just think about it. 3180, if you multiply 10 times. So if I make it 20 times, I will get this. Oh, approximately, if I make it into 20 times, approximately if I multiply 20 times, I will get this from this. So this is by 20 of it. So 100% I can write small r as Re plus Re by 20. So which is 21 Re by 20. Oh, maybe that's why the number 21 has come. Maybe that's why the number 21 has come. Oh, now it makes all sense. So now we can solve the problem. Now we can solve the remaining part of the question. Okay, so this will become GMM. This is 1 by R minus 1 by 2 times of small r. That means 2 times of 21R divided by 20, guys. 21R by 20. Great. So 20 goes on the top. R also comes outside. So GMM divided by R. 1 minus this 20 will go on the top and this will become 42. Is that right? So this will become GMM by R. 42 minus 20, which is nothing but 22, and this is 42. So this will become 22 and 42. So divide by 2. So 11 GMM divided by, this is nothing but 21R. So the answer should be 11, I believe. Yes, it is 11. Perfecto. Perfecto. It is 11. Got it, guys? Yep. It is not D. It is not D. It is B. Some of you made a mistake there. Yeah, it is 11 times. So that number X, the value of X is 11 over here. So this is that value which we wanted. Cool. Understood? So such kind of questions also come. These are just manipulative questions, guys. You have to just manipulate. How you got E2? This, I got it from this formula. Where is it? Energy of a satellite. Energy of a satellite minus GMM by 2R. So the total energy, which is kinetic plus potential, this is what it is. So in this particular problem, because it was in the orbit, so this will be the total kinetic and potential energy minus GMM by 2 times of R. Is that okay now? Clear? Absolutely. Pranad? Perfect, Jarvis. All righty. So let's move, guys, to the next concept of electric potential now. Electric potential is like your potential energy per unit mass or per unit charge. Think of it like that. So instead of finding the total energy, you find it per unit mass or per unit charge. That is what you will get. So if you had a mass over here and you are at a distance r, there is no mass kept here. There will be potential at that point, and that gravitational potential at that point will be negative gm by r. There is no mm on the numerator. Minus gm by r. That's it. So that's the gravitational potential at that point. And you can relate electric field and gravitational field just like you could relate force and energy. Remember the conservative force, I just did it, minus du by dr. Remember that? Minus du by dr. Instead of energy, I can put potential and then divide the same thing with the dr with a negative sign. What I will get is, instead of force, I will get the electric field or the field in general. So this is nothing but your field. So field is minus dv by dr or force is minus du by dr. One and the same things, guys. One and the same things. Force is minus du by dr or field is minus dv by dr. And you can see, if I take dr on this side, dv will be edr, and I can integrate it if you want. So if I integrate also, that is applicable, that is allowed, there is no problem with that. All right. There is also one more formula which you should know. Say for example, there is a line on which the potentials are same, that is called as an equipotential line. Another line is there where the potential is V2, and then what happens is you take a charge, doesn't matter what the path is because it's a conservative force. You take a charge from this point to this point. So there will be a change in the potential energy. So that change in that potential energy will be nothing but the charge that you have taken into the potential difference between those 2 points. So this is also a very important formula. The change in the energy from one point to the other, one potential to the other, is the charge into the voltage difference. You have used this even in modern physics, de Broglie wavelength. A charged particle is accelerated through a potential difference. The kinetic energy that it gains is E into V, the voltage that you accelerate and into the charge, QV or QE, whatever, you might have seen these formulas. So that same concept is used in modern physics also. So keep these things in mind. So you can see voltage is energy per unit charge. Voltage is nothing but energy per unit charge. So that's why even if you see over here, it is energy per unit mass or energy per unit charge, whatever you want to say. So the unit in case of electricity, it is volts, and that volts is nothing but how many joules of energy changes there per unit coulomb. But in case of gravity, it is nothing but joule per, instead of coulomb, it will be kg, joule per kg. So this is for gravity only. This is for electrostatics. Okay. So keep these things in mind. Everybody, cool? Shall we do some questions then? Shall we do some questions on gravitational potentials? What is the potential at what is it? The center. The center of a half ring of radius this much. Okay, this is just a half of the ring. Let's draw half of that ring then. Okay. So the radius is given, the radius is, let's say, R, and the charges are there everywhere. The charges are there everywhere. And the question is, what is the potential at the center? You have to find what is the potential over here at the center. This is the center. Now I'll tell you one thing. The total potential at the center is the potential due to each and every single charge. So I can say it is integral of dV. When I say integral of dV, you take any charge over here, which is, let's say, dq. Due to dq, there will be some potential, which I will call it as dV. So you integrate all the potentials, meaning add all the potentials, you will get the total potential. And potential being a scalar quantity, I can just add it. Yes, remember, potentials are scalars quantity. They are always scalars. So you can just add them without worrying about their directions. That same concern you will have to show for electric field, because electric field was a vector quantity. So in electric field, you have to worry where the direction is. You have to do vector addition. But in potentials, there are no worries. Only the signs are important. You can just directly add them. Okay. So it will be integral. What is the dV? Potential due to a point charge will be K dq divided by the distance, which is r square. K is a constant, even r square is a constant, correct? Even r square is a constant. So inside the integral, I just have dq. What is integral of dq? It is nothing but the total charge. It is nothing but the total charge. So it will be K by r square into q. But how much is that total charge is the question. How much is that total? How much is that total charge is the question. So it will be K r square. I think linear charge density is given. So that will be lambda into the length of this wire, which is just pi r. Do you understand why the charge is lambda into pi r? Think about it. Think about it, my dear students. Lambda is how much charge is there per unit length. How much charge is there per unit length? So charge will be lambda into the length, guys. Lambda into the length. Keep that in mind. Oh, so therefore it is lambda into pi r. because it is not complete circle. Okay, so RR cancels, so K lambda pi. K lambda pi will be the answer, but I think K value we have to put or what? I don't know. Lambda is given, I think. Lambda is given, yes. So 9 into 10 to the power 9. Lambda is 4 nano. So 4 into 10 to the power minus 9. And then we have pi over here. 9 fours are 36. So 36 pi. And this will be in volts. So that is the total voltage. Everybody with me? Cool. So answer is 36. Perfect. There we go. Answer is 36. Yes, Asmita. Perfecto. Great, guys. Awesomeness. 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 All right. Okay. So that was potential, guys. So let's move to the next question on your screen. A body is released from the height equal to the radius of the earth. The velocity of the body when it strikes the surface will be how much? This is also a very common kind of question where you cannot use kinematics equation, because a lot of people in the exam, they use kinematic equation saying S is ut plus half at square or v square is u square plus 2s. That will not work over here. So the body is released only from a height of r. So this is r, guys. Okay, so that particular mass was here and this was at obviously rest, and by the time it hit the surface it had some velocity. Question is, what is the velocity with which it strikes? The reason why kinematics is not applicable is because acceleration is not constant. So please mind, very, very important, don't use kinematics. So don't use kinematics. Why should you not use kinematics? Acceleration due to gravity, is not constant because the height is good enough. It's not few meters or a kilometer. It is 6,300 kilometers. That's the radius of the earth. So you cannot use it, guys. Okay. So the only option is we have to use energy conservation. That will help us. So initial kinetic energy plus initial potential energy, whatever it is, will be the final kinetic energy plus the final potential energy. Energy conservation. Initially, the mass is on the top at rest, so zero energy. Potential energy will be minus gmm divided by 2r. Why 2r? This point to this point, total distance is r plus r, which is 2r. This is equal to, when it hits the surface, the kinetic energy will be half mv square. Potential energy on the surface, think the mass is here, the center of the earth is here, the separation is r, so it will be minus gmm divided by r. Is that right? Okay. So mmm gets cancelled. Bring this guy over here. So it will become gm by capital R. And this minus gm by 2r will remain as it is. And from here, m has got cancelled. So it will be v square by 2, I believe. Yes, perfect. So what will happen? Gm by r minus gm by 2r. So it will become gm by 2r again is equal to v square by 2. 2 cancels. So v square will become gm by r. But we all know that gm is gr square. Now you'll be like, sir, from where do you remember such formulas? So guys, we know on the surface of that particular planet, the acceleration due to gravity is gm by r square. So capital Gm is small g r square. So that's how I remember. Okay, so Gm, I can write it as gr square, right? So r gets cancelled and I'm left with gr, but that's v square. So v will be root gr, not root 2 gr. So root gr, which is D option for IIT Delhi. Got it? Yep, D option, very good. Adam, Juko, Janwan, excellent, Abhishek. No, Shraddha, it won't be root 2 gr because you cannot use kinematic equations. Yeah, not allowed. Cool? Great, great, great. Let's go to another question, and before that, equipotential surfaces, I think I've already discussed. Equipotential surfaces are those surfaces which are having the same potential And remember that for a point charge, the equipotential surfaces are concentric spheres. One important property of equipotential surfaces is that if this is potential 1, this is potential 2, they are always perpendicular to the electric fields. They are always perpendicular to the electric fields or even the gravitational fields. And if the electric field or the gravitational field is going from this point to this point, that means the potential of 1 will be higher and potential of 2 will be lower, meaning the field always goes from higher voltage to a lower voltage or higher potential to a lower potential. Keep these points in mind. Okay. So let's do a brilliant question which was there on equipotential surface, and this blowed many students' mind. Very unexpected question which came in January attempt, where there were 3 infinitely long wires and they are placed along x-axis, y-axis and z-axis. Which of them denotes an equipotential surface? Which of the following denotes basically an equipotential surface? Very amazing question. Very amazing question. So I'll tell you how to do this particular question. First of all, you start off by taking a simple wire, let's say along the y-axis. And let's say you are at some distance from it. And at that particular distance, I ask you, what is the potential? Like, I don't know the formula for potential, but I know the formula for field. And the formula for electric field is, remember, 2k lambda by r. 2k lambda by r. That is what it is. Perfect, everyone? Okay. And now we know that the equipotential line for that guide, for that long wire, will be a ring like this. In fact, a cylindrical ring like this. Yep. Think of it like that. Because at all these points, the electric field will be perpendicular. It will be like this. This is how the electric field would be. So this is your equipotential line. Equipotential line. Is that right, everybody? Yep. That will be nothing but your equipotential line. Perfecto. Great, great, great. And to find out the potential, what we can do, we can think that electric field and potential are related by dV by dr. So to write down like this, minus dV by dr is your electric field, and electric field has 2k lambda by r. This is minus dV by dr. Take it over here. So dV will be with a negative sign, 2k lambda, and then you have dr divided by r. Now you just put up integration over here, integral over here, integral over here. Just do it with a constant of integration, it's okay. So the potential will be, or you can put V1, V2 also, it's okay. It will be minus 2k lambda, and this will be 1 by x's integration, which is log of x. So ln r plus some constant. So it's okay. We can always put log of r, and we can put ln some constant over here, some constant as it is. So this will become minus 2k lambda, and this will become ln log a minus log b is log a by b. So ln r by c. Is that okay? This is just some constant of integration. Think of it like that. So this is the potential due to the wire in the y-axis. Now, if that wire is in the y-axis, you take any point over here. You take any point over here, guys. Just think logically. Just think logically. This is your y-axis like this, and you take any point over here, because this is your x-axis and this is your z-axis. Any point on that particular equipotential line, this distance is your r, and that distance r obviously can be found by Pythagoras theorem, because this will be your x coordinate and this will be your z coordinate. So can you see that r technically will be root of x square plus z square? that r will be hypotenuse, will be x square plus z square, any point on that equipotential line. How many of you are able to visualize this? Everyone? Yeah. So that equipotential line is in the horizontal plane. So any point on that circle, the equation of a circle, guys. So one is x-axis, one is z-axis. So x square plus z square will give me r square. Yep. So I can say now that potential, because of that wire in the y direction, will be some constant, doesn't matter, ln. Here we'll have x square and z square, whole thing divided by constant. When there is y, there is x and z. So therefore, I can say due to the wire in the x direction, due to the wire in the y direction, due to the wire in the z direction, there will be some constant everywhere. Here, because there is x, when there is y, there is xz. When there is x, there will be yz. So there will be y square plus z square by constant. Here there will be x square plus z square by constant. Here there will be x square plus y square divided by constant. So when I add them, I will get the total potential, which is nothing but constant. And oh, sorry, I forgot the logarithm, my bad. Ln was there, ln was there. So constant log this plus this plus this, ln this plus this plus this. We know log of a plus b plus c, log of a plus b plus c, log of a plus log of b plus log of c will be log a into log b into log c. Yep, so this will be nothing but ln this into y square plus z square by c into x square plus z square by c into x square plus y square divided by c. That is what I will get. Log a plus log b plus log c is log a into b into c. Okay. And this is your net potential. And what was the question? Don't forget the question. The question was, which is equipotential surface? Equipotential surface means this must be a constant. If this is a constant, this is a constant, this is constant, this is constant, this is constant, whatever is there inside this whole thing, guys, meaning what? This particular thing, this must be a constant because this is a constant. So therefore, I will say y square plus z square multiplied by x square plus z square into x square plus y square is a constant. That is what the logic will be. Should we memorize the final formula? No, don't do that. It is just a question, guys. Yeah, it is just a question. Yep, don't memorize it. Don't memorize it. Cool. So I think it is this, obviously. So this is the equation of that equipotential surface. It's a brilliant question on how mathematical JEE mains can get. This is also a good, I would say, an example to show mathematics can be involved by a great deal in physics. And you should not expect that they are two distinct things. Mathematics will be only there in maths and physics will have only physics formulas or physics concepts. No, statement based, nothing like that. They can complicate the question and give it to you. So this was a good question. Those of you who were able to solve this at that moment, really hats off to you. Okay, electric dipole. Well, if you take a electrical dipole, gravitational dipole does not exist, by the way. Okay, so you take two charges separated by a distance. Charge is q, distance is something. Charge into the distance gives you the dipole moment. Yep. So this is that formula of dipole moment. Let me block it. This is your dipole moment. Two charges equal and opposite separated by a distance is called as a dipole. Okay. So this is positive, this is negative. This is how the dipole moment will be. It is a vector quantity. Now, if you find the potential and field due to a dipole, two formulas, guys, which you should remember. If there is a dipole, around it there will be electric field lines, equipotential lines. At any distance r from it, the potential is given by k p cos theta by r square, not r, cos theta. What is that theta? The angle which you are making with respect to the dipole. Yes, the angle which you are making with respect to the dipole. Your dipole is here, whereas where you are standing might be, oops, where you are standing might be somewhere else. So maybe you are standing over here. So that is the distance at which you are standing and you are making an angle of theta. Okay. So when you are standing there, how much electric potential is there? That is given by Kp cos theta by r square. At that point, you will also maybe experience an electric field, and that electric field might make some angle with your position vector. So that is alpha. So the value of that electric field is given by, the value of that electric field is given by Kp by r cube, root 3 cos square theta, root of 3 cos square theta plus 1. 3 cos square theta plus 1 is there completely inside the root. And the angle which the field makes with the position vector is given by half tan theta is tan alpha. Sometimes people write it like this, that is easier to remember. Tan of alpha is tan theta by 2. Theta is this angle, do not get confused. The position vector with the dipole. Alpha is the field with your position vector. So this is another important formula, guys. Is that okay? So all these formulas regarding fields and potentials due to a dipole. Similar formulas also there in magnetism. Next, if you take the dipole and place it in a field, then remember always the net force is always going to be 0. Yep. In a uniform field, the net force is always going to be 0. In uniform field, in uniform external field, but there is a torque acting on it, and that torque is given by magnitude wise, it is dipole moment into the field into sine theta, but vector wise it is P cross electric field. So that is the value of the torque that you get. It is P cross E, or P is sine theta. Theta is the angle made by the field with the dipole moment. Notice how the dipole is over here. Notice how the dipole is over here, whereas the electric field is over here, and the angle which you are making with the dipole is over here. Same thing, potential energy, guys. The potential energy is given by minus P cos theta, or just minus P dot producted with E. Yeah, the dot product has to be considered. So this is your potential energy, minus P cos theta, minus is there, or you can take minus P vector dot producted, scalar producted with electric field. That is the potential energy of the dipole in that external field. Let's do some questions. What do you think? There is a dipole placed at a distance of 2 centimeters from an infinite plane sheet having positive charge density sigma. Choose the correct option in the following. Come on, guys. What do you think? What do you think? See, there is a uniform charged sheet. So due to that charge sheet, there will be obviously electric field which will be going like this. There is a uniform electric field which is coming because of that sheet. So this is the uniform electric field due to that sheet. And if you look at this particular dipole in this case, negative to positive always. So that is your dipole moment. That is your dipole moment. The dipole moment is parallel to the external electric field. That means the angle which is made is 0 degree. The potential energy will be minus PE cos 0, which is minus PE, which is minimum, number one. Next thing, the torque will be 0 because P cross E will be 0. PE sine 0 will be 0. So it is in equilibrium and it has minimum energy. Torque is 0. Torque is 0 and net force is not away. Potential energy and torque are maximum. No, it will be option B, I believe. Potential energy is minimum and torque is 0. Perfect. Yes, the torque is 0 as you can see, and potential energy potential energy is minimum. Perfect. No other option will match. Negative P is the least energy. Positive P is the maximum energy which will come if the dipole was anti-parallel, meaning 180 degrees with the field. That would be unstable equilibrium. Perfect. Okay. Moving on to the next question, guys, on your screen. There is a dipole, charge length in an electric field. Dipole is rotated. Find the time period. Oh, this is a nice question. There is an electric field. There is a dipole, and obviously then there will be a torque acting on that dipole. So that torque will be restoring in nature. And because that torque is restoring in nature, that is the reason why that dipole will oscillate. It will oscillate. It will oscillate in that dipole will oscillate in that external electric field, and you have to find the time period of oscillation. So let's see how much the torque will be. The torque will be nothing but the dipole moment into the electric field into the sine theta. But what is that dipole moment? Let's find out. Dipole moment, guys. Charge is q, length is L. So any one of the charges into the length will be the dipole moment. Electric field will be as it is, so I'll put E. But for small angles, sine theta will be theta. This is your small angle approximation. Small angle approximation. So as you can see over here, our torque is directly proportional to theta. So whenever torque is directly proportional to theta, whatever is there inside, that becomes your constant of proportionality. So therefore, when I try to find the period, when I try to find the time period, which is 2 pi under root moment of inertia upon that constant of proportionality. So 2 pi is there as it is. What is the moment of inertia? Well, length is L in a uniform electric dipole of mass M. Okay. So what do you think is the moment of inertia? What will you write the formula for moment of inertia as? Think about it. Yeah, draw the diagram. That will be better for you only. So if this is our dipole, guys, okay, and these are the masses, this is M, this is M, this is your axis about which it will rotate like that. So each of this much distance will be L by 2. This much will be L by 2 because the total length of the rod was L. So what will be the moment of inertia? I think the moment of inertia will be mr square plus mr square. That means m L by 2 square plus m L by 2 square. That is your moment of inertia by the constant of proportionality, which is Q, L and E. Q, L and E. Yes, everybody with me? Very good. Excellent. So the question is, what is the time period? Come on, guys. Now you can easily get it. Now you can easily get it. What is the answer? What is that answer? This is 1 by 4. This is also 1 by 4. 1 by 4 plus 1 by 4 is 1 by 2. So 2 will come in the denominator. So L will also get cancelled. So ML by 2 Q E naught. Yeah. So I think it should be B option. Just check it out. Yes, it is B option. You solve this, guys. 100% you are going to get this B option. Yeah. 1 by 4 plus 1 by 4 is 1 by 2. So 2 will come in the below, not on the top. And no, it is not even A option, guys, because A option says 1 by 2 pi. No, it is not 1 by 2 pi. Yeah. Okay. Yatra, we will be doing VIT PYQ session maybe after JEE Mains first attempt. Sorry, second attempt, my bad. And also, meanwhile, I hope you know that we have a VIT course also with the PYQs, strategy sessions, everything included in the JEE crash batch. Yeah. So remember, there were 3 variants. This is the crash prime, which is proper online batch with live classes, recordings available, all India level test series and portion completion, pedagogy access, VBuddy classes, everything is there. But the second variant, I'm not sure if you have seen this. This is VIT plus KCET, because many students from South appear for KCET or ComEd K or VIT exams. This is that combo which we have. So KCT Comet K test series, VIT EEE strategy sessions and PYQ discussions. There are many discussion sessions lined up over here. VIT EEE special classes discussions are there in this particular batch, the Crash combo. And the Crash Pro, well, that is basically considering that if you want, what do you say? You want that all India level test series separately, apart from the regular tests for VIT EEE and KCT, you want all the engineering entrance tests, like you have MHT-CET, West Bengal JEE, CUET, BITSTAT, everything in one go. Then you can go for the third variant, which is your Crash Pro variant. All the three variant links have been placed in the description box. Okay, you can check it out. Yes, yeah. Yeah, so the VIT EEE classes in that crash course will start immediately after the second attempt. Yeah, immediately after the second attempt. Okay, cool. Perfecto. Let's go, guys, to the next question. For a short dipole which is placed in at the origin, the dipole moment is in the x-axis, as you can see over here. The electric potential and field at point A are V and E naught. The correct combination of the potential and field at point B, the distance is doubled. Okay, let's think about it. First of all, if you are at point A, what is that electric field given by? Kp 3 cos square theta, all that will be there, right? Okay, so let's think about it. So if I'm here, this is a dipole. So electric field, this will be on the axis, axial field, that means theta will be 0 degree. So that will be Kp by r cube 3 cos square 0 plus 1, which is 2 Kp divided by r cube. So that is your E naught. Similarly, you can find your V naught. V naught will be Kp cos 0 divided by r square, which is just Kp divided by r square. That is your V naught. Great. Now let's go over here first. Finding the potential at point B is very simple. It will be Kp cos 90 by 2r square, which is obviously 0. So potential is definitely going to be 0. So 0 and 0. A and C options are automatically eliminated. The field at point B will be Kp by r cube. Here you have 3 cos square 90. Yep, plus 1 over here, everybody. Yes. So what is this going to be? Cos 90 is 0, so it will be Kp by r cube. That was, but this r is going to be 2r. So this will be 8r cube. Yeah, this will be 2r cube. So this will be 8r cube. So if you compare that with this, the E naught value, just check this out. This will be 1 by 8 times of Kp by r cube is nothing but E naught by 2. Kp by r cube is E naught. If you divide by 2, that is what you will get. So therefore, this is E naught, 8 to the 16. So electric field at point B is E naught by 16. So E naught by 16 is there over here. So D option should be the right answer. Yes, it is the right answer. Got it, my dear warriors? Perfecto. Very nice. Excellent. Moving on to escape speed formula. Standard formula, guys. When you throw a mass with such a speed that it is able to reach infinity, then you have said that you have thrown the mass at an escape velocity, and that formula for escape velocity is the root of 2 times g times mass of the planet by the radius of the planet. Please note, it is independent of small m angle. It is independent of small m angle also. What angle you throw it at, it doesn't really matter. All the angles are acceptable. And keep this in mind, if by chance, if the escape speed is more than equal to the speed of light, then it implies the planet has turned into a black hole. This c is the speed of light. This is the speed of light. The escape velocity, standard formula, escape velocity for Earth, the escape velocity on Earth approximately is 11.2 kilometers per second. On Moon it is less, Jupiter it is more. It depends on the mass and the size of that particular planet on which you are conducting that escape speed experiment. So it's 11.2 kilometers per second. Anything thrown at that speed will escape Earth's gravitational pull forever, assuming air resistance, rotational effects, and other planetary effects are neglected. But when you consider that, obviously the speed will be much higher than this. What about this? Earth has a mass 8 times, radius 2 times. If the escape speed on the Earth is 11, then escape velocity on that new planet will be how much? That's the question. Come on. Direct ratio proportion based question, guys. I'm pretty sure you will be able to do it. Everybody should be able to do it. We all know the escape velocity formula is root 2 gm by r. So escape speed of that planet upon escape speed of Earth will be m2 by m1 and inversely proportional to root of r. So r1 by r2 will be over here. Okay, so this is v2, this is 11. This is v1 for Earth, v2 is for that particular planet. The Earth has a mass 8 times of that planet. So mass of the Earth is 8 times, so 1 by 8. Then the radius is 2 times. So radius of the Earth is 2 times. So this will be 2. Okay. So this will become V2 by 11. V2 by 11 is equal to 2 by 8 is 4. So 1 by root 4, which is 1 by 2. So V2 by 11 is nothing but 1 by 2. So V2 will be, sorry, this was 11.2, guys. 11.2. 10.2. So 11.2 divided by 2. So therefore V2 will be how much? 11.2 divided by 2, which is 5.6. 112 divided by 2 is 56. So 5.6 kilometers per second. So that is your escape speed. Just check this out. Yes, option C. So here you have to be very careful. It's inversely proportional to radius root and directly proportional to the root of the mass. So this was the planet, this was the Earth. That's what I have considered over here. This was your planet V2 and this is your Earth. So everything related to the Earth is with 1. So mass of the Earth is 8 times of the planet. Radius of the Earth is 2 times that of the planet. So substitute it properly. If you make a mistake, that's it, it's gone. You will get some other answer. Yeah, it is C option. Perfecto. Moving on to the questions on electrical flux and Gauss's law. Remember, flux is nothing but flow of the field and it is directly proportional to the number of field lines piercing through an area. If it doesn't pierce, there is no flux. Yeah, and the flux, the electric flux is just given by integration of field into the area vector, integration of the field into area vector. So if you have an area which is like this, the area vector is always perpendicular to that. The area vector is always perpendicular to that surface. So this is your area vector. This is your ds area vector. The electric field at that point, so this was your area vector ds bar. The electric field at that point might be in a particular direction. So maybe this is electric field. So this electric field will come over here and then obviously take a dot product between them. That will give you the electric flux. That will give you the electric flux. If you ask me the unit of that electric flux, first of all, this is a scalar quantity. Please mind it. Yeah, it is a scalar quantity. The unit will be the unit of field into the unit of area. Field is volt per meter. Area is meter square. So it will be basically volt into meter. Volt into meter will be the unit of electric flux. Also keep this in mind that if you have a closed surface, then all the flux which comes out of it is considered positive Whereas all the flux which goes inside that closed surface is considered as negative flux. Is considered as negative flux. Positive, negative matters a lot in calculations of cubes, cylinders, etc. Sign will matter. You cannot ignore just because it is a scalar quantity. The Gauss's law says that the total flux in a closed surface, that's why you have this particular cyclic integral. As you can see, this is closed surface integral is always the net charge inside by epsilon naught. Total charge which is there inside by epsilon naught gives me the total electric flux. Although the total flux only depends on the inside charge and not on the outside charge, mind it, the left hand side, the electric field depends on both inside as well as the outside charges. Okay, the net electric field always depends. So this particular E is due to both inside and outside charges. But the right hand side, it's only dependent on the charges present inside. So that is what you should know. Let's do a question coming up on your screen, guys. Yep. There is an electric field which is 2x I cap. I cap says that the electric field is in the right hand side, and x says that the electric field is variable. Okay. Side of the cube is 2. The electric flux through the cube is how much? That's the question. Okay. Come on. Ready for it, guys? Everybody? Yes. Last few questions coming up on your screen. Yeah. Very few questions are remaining now. Very few questions are remaining. Okay. Now, over here, we know electric field is going in the horizontal direction. So, if the electric field is going like this, then if you have a surface like this, or if you have a surface like this, the flux through that will be 0. The flux through that will be 0 because the area vector will be perpendicular. Area vector will be perpendicular. It will not pierce through it. So there will be no flux contributed because of that. The only flux will be contributed because of this face here and this face here. That's it. These are the only two faces which contributes in the electric flux. Here, there will be some amount of electric field which we will calculate. Here also there will be some different amount of field because it varies with x. We need to be careful. At this particular point, the value of x is 2. At this particular point, 2 plus 2, which is 4. So the electric field on the left face, 2 into x is 2. So I cap. So that will be 4 I cap Newton per coulomb. Electric field on the right side face, well, that's x is 4. So 2 into 4 I cap. So it will be basically 8 I cap Newton per coulomb. Now I want to find the total flux of that cube. Total flux of that cube. The only contributors are left face and right face. The top, bottom, front, back are not contributing. That's very, very important. Yep. So this face is nothing but, and this face is nothing but, this is one on the top or at the bottom, and this one at the front or at the back. They are not participating in the flux. So only the flux due to the left face plus flux due to the right face. Now please mind it, the flux on the left face is because the field is coming inside, so it should be negative. So negative into the field is 4 multiplied by the area is 2 into 2, so it will be 2 multiplied by 2. Yeah, do you get it? Negative, why it is? Because it is coming inside. This is your field and this is your area. Then plus right side it is coming out, so it is positive, don't worry. Field is 8, area is again 2 multiplied by 2. This is again your field and this is nothing but your area. Okay. So how much is this? 2 to the 4, 4 4 is 16. So minus 16 plus 2 to the 4, 4 8 is 32. So 32. So 32 minus 16 is again 16. So 16 voltmeter is that flux. So that's the answer. Yep, perfect. Yeah. So if you miss the sign, you will get a wrong answer. Many people added it and they added 16 and 32 and gave the answer as 48. Many people gave that answer as 48. Got it? Everyone? Very good. Excellent. Excellent. Let's do the next question. There is a line charge of A by 2 which is kept on this edge BC. Edge is BC. Okay, line charge is kept and length is A by 2. So something here like this. This is positive charge like that. At the center of the edge BC of this cuboid or cube, the edge length is A. The density of the charge is lambda per unit length. The total flux through all the faces of the cube. Oh, this is interesting, guys. I mean, what we can do, we can visualize this into 4 new cubes now. I'll just try to make you visualize this. Very interesting it is. Just imagine one more cube over here in front. And then imagine more cubes over here. It's going to be very interesting. See if you're able to visualize now 4 cubes. Are you able to visualize this? A 3-dimensional structure. Yep, perfect. So now imagine electric field lines coming out of that line charge. What will happen? Some of the field lines will go through that cube, some field lines will go through this cube, some field lines will go through this cube, and some field lines will go through that cube. 4 cubes it will go equally. So think of it this way, the total flux would be the charge by epsilon naught, but that flux is divided in all the 4 cubes equally. So the flux through any one of that cube multiplied by 4 is nothing but q by epsilon naught. So the flux through that particular cube is 1 by 4 q by epsilon naught. But what is that q exactly? It is lambda into the length, which is a by 2. So it will become lambda a by 8 epsilon naught. Lambda a by 8 epsilon naught, which is option B, of course. Why q becomes lambda into a? The reason for that we all know is lambda is how much charge is there per unit length. So charge will be lambda into length. Lambda is lambda only. Length is a by 2. Yes, this particular length was a by 2 and this was the charge on it. So that's why lambda into a by 2 is the charge on it. So beautiful question, guys. Yeah. How many of you were able to solve this when you saw that question, maybe? Or if you're watching it recorded also, maybe you can post it in the comments, because this was one of the most interesting question, because so many visualizations are needed. I mean, think of a cube in front, below, and below this also. So the flux will get distributed equally, because now that charge will be completely inside those system of 4 cubes, and by symmetry, because that charge is exactly at the center, you can see it will split equally in all the 4 directions. And that's how you get the answer. Isn't it amazing question? Okay. So let's go to the last part, which is Kepler's laws. Quickly, let's go through it. Any small mass going around a massive body like the star or the sun, or a planet going around the sun, obeys these Kepler's laws, which can be independently derived using Newton's laws. Kepler found out these laws purely by observation without the use of Newton. And it's said that Kepler, obviously was a great astronomer, scientist, uh, and that was a great miraculous discovery by Kepler, although he was killed for his discoveries. But it was at par with Newton's law of gravity, because without any formulas he derived this. So the first law was The planets move around the sun in elliptical orbits. The planets move around the sun with the elliptical orbits with the massive body at the focus. It's not necessarily the sun. It could be some heavy planet or heavy star or some point mass which is very heavy. So that is always at the focus of that ellipse. The second law is the line joining the sun to the planet sweeps out equal areas in equal times. So law of areas. And it is also said that the areal velocity, the area swept per unit time, is angular momentum by 2 times of m. This is going to be constant because angular momentum is conserved. This L is your angular momentum. Yeah, that is your second law. The third law is the square of the time period is proportional to the cube of the main distance. Yes, the square of the period is proportional to the cube of the distance from the sun, or cube of the radius from that sun. So this is the third law, from which if you know the radius of the orbit, you can find out the time period by ratio and proportions. These are the three laws. Elliptical orbit, massive body at the focus, second law. Area which is covered per unit time. If you join the line from the sun to the planet, it will sweep an area per unit time, is angular momentum of that planet by 2m, which is a constant. Third law, square of the time period of revolution is proportional to the cube of the distance from the sun and the planet. These are the three laws. Let's do some questions, guys, quickly. Two planets, masses m1, m2, moving around the sun in orbits r1, r2. Angular momentum is L and B is 3L. The ratio of the time periods is, come on, very nice. They have coupled 2-3 laws together. Yep. Can you figure this out now? Can you figure this particular out? Think, guys, carefully. The angular momentum of A is L and B is 3L. So if you write for A first, angular momentum will be mass m1. Yep, mass is m1. Radius, I do not know. I'll put r1. Velocity, I'll just put v1 over here. Yeah, that's what I can do, everyone. Similarly, if I do for the second mass, the angular momentum is 3L, mass is m2, radius I do not know, velocity is v2. So from this, I can just probably take the ratio. R1 and R2 are the radius. Okay. From that, maybe I can get something. Let's see. What is the question? The ratio of the time periods they have asked. Okay, so what we can do? Let me just put this over here. So this will become M1 R1 V1 3 times L is nothing but M1 R1 V1 will be M2 R2 V2. This is one of the equations which I get. This is one of the equations which I definitely get. Now, what else is given? What else is given? Time periods is asked. So time periods, I know T1 and T2. That will be squared, and that is proportional to R1 by R2 the whole cube. R1 by R2 the whole cube. Oh, so if it is R1 by R2 the whole cube, R1 by R2 the whole cube, what we can do, think over here. Can I somehow find R1 from R1 by R2 over here? Yes, definitely. I can find that directly over here, guys. Everyone. So let me find out what is R1 by R2 from here. So R1 by R2 will be, check this out, M2 V2 divided by 3 M1 V1. 3 M1 V1. Substitute it directly over here. So see, what do you get? M2 V2 divided by 3 times M1 V1 the whole cube. This is your T1 by T2's whole square. But we are nowhere close to the answer because I do not want V1 and V2. I do not want V1 and V2. Can we somehow get rid of V1 and V2? Can we somehow get rid of V1 and V2? Then only we can solve the question. I think so. We can get rid of V1 and V2. I'll tell you how. We know in general for any satellite which is moving around a planet, the the velocity is given by root gm by r formula. So it is inversely proportional to root of r. So therefore v1 by v2, won't it be root of r2 by r1? Won't it be proportional to root r2 by r1? Yes, perfect. Very good. So let's get rid of v1 and v2 directly like that. So from over here, when I write m1 by m2 is nothing but r2 by r1, and that number 1 by 3 also comes, and this will become v2 by v1. I can write this as r2 by r1 into 1 by 3. Instead of v2 by v1, I can write it as r1 by r2's root. Now root r1 will cancel. Same thing, root r2 will cancel. So I will be left with 1 by 3 and root of what will be there on the top? R2 will be there, and here R1 will be there. So that is what now your M1 by M2 will be. M1 by M2 is 1 by 3 root R2 by R1. So let's put that over here. But before that, square this, guys. Only then we will be able to substitute it. So squaring both sides, I will get this M1 by M2 whole square. M1 by M2 whole square will be 1 by 9 into R2 by R1. So therefore R1 by R2, check this out, R1 by R2 will be nothing but M2 by M1 the whole square, and this 1 by 9 will be there. Take R1 on the top, take R2 below. 9 is as it is. M2 goes on the top, M1 comes below. So now substitute it over here instead of R1 by R2. So it will be M2 by M1 the whole square into 1 by 9. And this is the whole cube, of course. And this is T1 by T2 the whole square. Now if you just write T1 by T2 taking square roots, what will it be? Square root of square will be that same thing. So it will be M2 by M1. 1 by 9 square root is 1 by 3. So this cube, of course. So what else is there? Yeah, 1 by 3 cube is 1 by 27. And this will be M2 by M1 the whole cube. So M2 by M1 the whole cube, 1 by 27 is there. Yep, perfect. It is 1 by 27. D option. So this is a very crazy problem because it involves many formulas and lot of manipulations. Beautiful question which was framed, guys. So amazing question because angular momentum concept from rotation is there. Then the concept of speed relation with the radius is there. Then how you manipulate and get rid of velocity. And then the Kepler's third law and how you play around with these numbers. Beautiful, beautiful question. D option. Very good. Excellent. Let's do one more question. Satellite is launched. Second satellite is launched. Different radius. Time period of revolution of the satellite is larger than the first by approximately how much percentage? Okay, by approximately how much percentage? So what will you do in this particular question? Think about it. We all know the square of the time period is some constant into radius cube. Okay, so therefore t will be some new constant. If this is old constant, this is new constant, r raised to 3 by 2. Oh, so therefore by the logic of errors, delta t by t relative error, constant never matters. It will be relative error in the radius and the power will just come outside. Can you see delta r is 1.03 r minus r, that is the change, which is 0.03 times of r. Oh, so just put it over here. So that will be nothing but 0.03 times of r. Old radius is r. This is 3 by 2. So this is your delta t by t. But we want percentage change in the time period. So this will be 3 by 2. RR got cancelled. 0.03 multiplied by 100 so that we get it in percentage. So 100 and zeros decimals cancel. So 3 into 3 divided by 2 percentage. 9 by 2 percentage, which is 4.5 percentage. 4.5% is option C. Perfect. Yes. Work done by external force is the positive of delta U. work done by internal conservative forces is negative of the delta E. Is that okay? Leah and Mia Lily. Oh my God, what a name. Okay, great. So that was the final question of the session, and it was a wonderful session considering the kind of quality of questions that I have given to you with the theory, concept, understanding, how to solve it, how to think. Now, I want you to practice more such questions. Don't just be dependent on this session, of course, because I'm thinking the best of you. After the classes are over, whenever you are getting breaks, practice, practice, practice. If you are doing today electrostatics, gravity, practice all the questions from that. Whenever we are following a schedule, practice that day. So today you have some chemistry class, maths class, physics class. Today whole day spend on that. Next day whatever sessions are there, practice whole questions on that. Master these topics. Next week, my dear students, you are just going to have mock test and full revisions. Amazing, effective, power-packed revisions which are going to be done for the entire syllabus. Okay, so stay tuned on the channel. Smash that like button, subscribe to the Vedantu J English channel, the #1 English channel in the country. And of course, the PDF will be there in the description box by the end of the day. Okay. All the best, my dear students. Have a great time. Bye bye. Hasta la vista.